Now, this seems all very complicated, but let's do an example that will make it make more sense. Suppose a particle is in equilibrium with a heat reservoir at T equals 300 Kelvin. This particle can exist in three states with energies -1, 0, and plus 0.5 electron volts. Calculate the partition function for this particle. Number 2, calculate the probability that this particle is in each of these three energy states given above. Okay, so this is actually quite simple. How do we do this? So the first thing it's asking us is that we have to find at 300 Kelvin, what is the partition function for this particle? Now, there are three states that it can exist in. So how do I find the partition function? So I can use my equation Z equals summation e to the mu ni minus ei over kt, sum over I. So that's an equation I can use. I can also use the fact that I know that when my T equals 300 Kelvin, my KT will equal 0.026 electron volts. So using these two facts and the fact that I know that mu equals 0 for this case, my Z will reduce down to sum of E minus EI over KT. Now, there are three states that I know. So how will I write this? E to the minus E1 over KT plus E to the minus E2 over KT plus E to the minus E3 over KT. And then I can plug this value in here as negative 0.1 divided by 0.02 plus E to the minus 0 over 0.02 plus E to the negative 0.5 divided by 0.02. Or I can get 0.0214 plus 1 plus 46.805, or the value of my partition function comes out to be 47.82. Note, the partition function is dimensional. It does not have any units. Now, how do I find, so that's my answer to number 1. Now, number 2 is the probability that this particle in each of these energy states. So how do I find that? All I have to do is I have to figure out what is the probability of it to be in state 1. So number 2, probability of it to be in state 1. P1 is just E to the minus E1 over KT divided by Z, or E to the minus 0.1 divided by 0.02 divided by 47.82, or 0.0214 divided by 47.82, or 0.045%. Now, what is the probability of it to be in state 2? P2 is just E to the minus E2 over KT divided by Z, or E to the 0 divided by 47.82, or 1 divided by 47.82, 2.09%. And the probability for it to be in state 3, P3 will just be negative E3 over KT divided by Z, or E to the 0.5 negative 0.02 divided by 47.82, or 46.805 divided by 47.82, or 97.87%. So now there are two more examples that are given in the book. I strongly recommend that you guys do those. They are this one and that one.